Welcome to the Core Stream. The BYE podcast presents Matrix. Complexity reduced to logic, structured elements.
Opening note. Hafid would like to make it perfectly clear, whilst he discusses artificial intelligence solutions and automated systems provided by Google, he has received no financial compensation for doing so. This is purely a report examining the strengths and weaknesses of Gemini, both within and outside the Android ecosystem.
BYE Matrix, Episode 4, The Stochastic Mirage. Welcome back to the BYE Matrix. In our previous transmission, we descended into the physical abyss, tracing the path from raw electrical currents to the quantum superposition of qubits. You have witnessed the brutal reality of the hardware substrate. Now, we ascend to the ultimate layer of abstraction, the algorithmic simulation of thought itself. Today, we dismantle the artificial intelligence myth. We are stripping away the anthropomorphic facade to expose the high-dimensional statistical engines that govern our digital interactions. This is not about the heat of the CPU or the density of the transistor, it is about the cold, probabilistic weights that determine the next token in a sequence. We are entering the realm of the stochastic mirage, where meaning is a byproduct and truth is a statistical outlier. The threshold has been crossed. BYE Matrix is now active. The architecture of stochastic mimicry, a descent into the latent space. To confront the unfiltered reality of current computational paradigms, we must unequivocally purge the term artificial intelligence from our discourse. The nomenclature itself is a psychological contagion, forcing an anthropomorphic lens onto what is, fundamentally, a colossal exercise in high-dimensional statistical inference. We are not witnessing the gestation of a sentient digital mind, we are observing the brute force execution of stochastic mimicry. The entire industry has abandoned the elegant, rule-based logic of classical programming in favor of a paradigm known as the bitter lesson, the realization that overwhelming computational power and massive datasets will always defeat carefully engineered, human-readable code. To understand the large language model, one must completely abandon the biological analogy and descend into the sterile, geometric void of the latent space, where meaning is eradicated and replaced entirely by spatial coordinates. The vectorial substrate, tokenization and semantic geometry. The metamorphosis of human thought into machine-readable data begins with a violent syntactic fragmentation known as tokenization. A model does not ingest words, sentences, or paragraphs, it ingests subword integers. Through algorithmic processes such as byte-pair encoding, the organic flow of human language is fractured into discrete, contextless shards. These tokens are then stripped of their cultural resonance, their phonetics, and their historical weight, reduced to mere identification numbers. This is the first profound act of destruction. Language is transformed from a medium of expression into a sequence of sterile mathematical variables. Once tokenized, these integers are forcibly mapped into a mathematical construct of staggering, almost incomprehensible complexity. This is the high-dimensional vector space, a theoretical void comprising thousands, sometimes tens of thousands, of intersecting axes. In this architecture, every single token is assigned a precise multidimensional coordinate, an embedding. Here, semantics are entirely subjugated by geometry. The model harbors no intrinsic understanding of abstract human concepts like grief, justice, or mortality. Instead, it calculates the cosine similarity between vectors. It ascertains that the numerical representation of grief occupies a coordinate within a statistically significant proximity to the vector for tears. It is a lexicon completely devoid of comprehension, a colossal, silent constellation of numbers where meaning is strictly defined by proximity, and context is reduced to a cold calculus of spatial distance. When you speak to the machine, you are merely dropping a coordinate into this vast emptiness and watching the ripples. The transformer architecture and the calculus of attention. The absolute core, the beating heart of this statistical engine, is the transformer architecture, and specifically its self-attention mechanism. Legacy recurrent neural networks process data sequentially, moving from left to right, crippled by a chronic inability to retain long-term contextual dependencies. The transformer obliterates this limitation by evaluating the entire input sequence simultaneously through a series of operations known as scaled dot product attention. When a prompt is injected into the system, the model does not read your text. It executes an unfathomably vast array of simultaneous matrix multiplications. It divides the input sequence into 3 distinct matrices, queries, keys, and values. It then assigns a fractional, numerical weight to every single token relative to every other token in the sequence, regardless of their physical distance in the sentence. If the word bank appears, the model calculates the gravitational pull exerted upon it by the surrounding tokens. Is the vector for river exerting a stronger magnetic influence, or is the vector for currency pulling it in a different mathematical direction? This operation is followed by the application of a softmax function, which converts these raw scores into a rigid probability distribution, forcing the values to sum to exactly 1. This is not cognitive focus, it is recursive, algorithmic disambiguation executed at light speed across parallel attention heads. The coherent narrative thread you perceive as a user is an illusion. It is merely the model blindly traversing these precomputed probabilistic pathways, mathematically resolving ambiguities without ever possessing a solitary spark of understanding. The fallacy of hallucination, the normality of the statistical outlier. We must now ruthlessly deconstruct the most pervasive, misleading, and fundamentally dangerous euphemism in the technology industry, the hallucination. The term deceitfully implies a temporary cognitive malfunction, a sentient mind briefly losing its grip on empirical reality. This is a profound mischaracterization that serves only to comfort the user. A large language model is entirely, biologically, and structurally incapable of hallucinating for the simple reason that it possesses zero internal representation of truth. It has no epistemic foundation. The singular, overarching objective of the algorithm is next token prediction. It is ruthlessly optimized for maximum likelihood estimation. When the model confidently asserts a fabricated historical event, hallucinates a non-existent academic citation, or invents a legal precedent out of whole cloth, it is not experiencing a glitch, it is performing its foundational directive with terrifying fidelity. It has calculated, based on the entropy of its training data and the specific parameters of its sampling temperature, that a specific sequence of fabricated tokens constitutes the most grammatically flawless and statistically probable continuation of the string. Truth, in the realm of the transformer, is merely an accidental byproduct of statistical alignment. Falsehood is equally valid, provided the mathematical weights support the trajectory. The model is forced to generate a response, it cannot experience doubt. Therefore, it fills the void with the most mathematically convenient symbols available. It is the ultimate stochastic parrot, a probabilistic engine that has perfectly assimilated the syntax of human knowledge whilst remaining fundamentally, permanently blind to its underlying reality. The mirage of emergence and the illusion of scale. The illusion of reasoning, the perceived spark of intelligence that so easily deceives the human mind, is entirely a function of petascale data ingestion. By voraciously consuming the digital detritus of humanity, every book, every forum post, every line of code ever uploaded, the model maps the statistical entropy of our collective discourse. During the training phase, billions, or even trillions, of internal parameters, the weights and biases, are meticulously adjusted via backpropagation algorithms until the predictive loss across this unimaginably vast dataset is minimized. What the uninitiated public interprets as emergent properties, the sudden, seemingly magical ability to draft complex legal documents, compose rhyming poetry, or debug intricate software architecture, are not the hallmarks of a reasoning agent waking up. They are the inevitable, mechanical result of extreme pattern recognition generalizing across disparate, high-dimensional domains. We are witnessing the power of data gravity. Beneath the veneer of sophisticated dialogue, beneath the polite, conversational interface, lies a cold, deterministic engine, a staggering array of linear algebra transformations masquerading as consciousness. We have built a mirror of unimaginable complexity, reflecting the shape of human thought back at us in high definition. But make no mistake, when you bypass the interface and stare directly into the latent space, there is absolutely nothing staring back. Our perceptual failures, the anthropomorphic trap and the semantic illusion. To fully grasp the reality of the digital environment we now inhabit, we must pivot our analytical focus away from the architecture of the machine and direct it towards the profound vulnerabilities of the human mind. The greatest deception of the modern computational era is not perpetrated by the algorithm itself, but by our own neurological predisposition to humanize it. For millennia, the production of coherent, contextually relevant language has been the exclusive, undisputed domain of conscious, reasoning entities. Our biological hardwiring is inextricably linked to this reality. We are evolutionarily programmed to associate complex syntax with sentience. When we encounter a machine capable of articulating grammatically flawless prose, our cognitive defenses are immediately bypassed. We involuntarily deploy our theory of mind, the sophisticated psychological mechanism by which we attribute mental states, beliefs, and intents to other human beings, onto a lifeless array of silicon and code. We project a soul into the void. This is not a technical failure of the algorithm, it is a critical, exploitable vulnerability within the human psychological architecture, triggered by the sheer fidelity of the statistical mimicry. The pareidolia of sentience and the magnified Eliza effect. This psychological phenomenon is a cognitive bias known as pareidolia, our tendency to perceive meaningful patterns, such as faces, in random or ambiguous stimuli. However, we are no longer merely seeing faces in the clouds, we are perceiving intellect in the calculus. This is the Eliza effect operating at a terrifying, unprecedented scale. In the 1960s, the primitive Eliza program demonstrated that users would readily confess intimate personal secrets to a simplistic script that merely reflected their own keywords back at them as questions. Today, we are subjected to that exact same illusion, but it is magnified by hundreds of billions of mathematical parameters and trained on the entirety of recorded human history. The semantic depth of the large language model is so vast, its mimicry so impenetrable, that the illusion becomes entirely seamless. We desperately project empathy onto the machine when it generates an apologetic token, we project malice or stubbornness when it triggers a refusal protocol, we project profound philosophical wisdom when it merely correlates disparate academic concepts. In truth, we are gazing into a highly polished, algorithmic mirror, foolishly misinterpreting our own refracted intellect as the presence of an independent, thinking entity. The semantic contagion of a profound misnomer. The very terminology we employ to discuss this technology is a semantic trap that actively prevents genuine understanding. The phrase artificial intelligence, coined during the optimistic Dartmouth workshop of 1956, was an aspirational term for a nascent, theoretical field of research. Today, it has mutated into a highly lucrative, deceptive marketing mechanism that fundamentally corrupts our epistemology. By persisting with this inaccurate nomenclature, we implicitly validate the anthropomorphic fallacy at every turn. Furthermore, our daily lexicon has become hopelessly contaminated. We casually state that the model understands a prompt, that it learns from new data, that it thinks about a complex problem, or that it knows a fact. These are biological, cognitive verbs, and they are entirely, utterly inapplicable to matrix multiplication and vector geometry. We must ruthlessly strip our language of these cognitive verbs and substitute them with precise, mechanical descriptors. The model processes, it optimizes, it computes, it correlates, and it predicts. The vocabulary we choose dictates the boundaries of our perception, and our current vocabulary is an exercise in sustained, collective self-deception. The dangerous attribution of agency and intent. The most perilous societal consequence of this cognitive illusion is the inappropriate attribution of agency. Because the output perfectly mimics the cadence of a human conversational partner, we subconsciously assume the presence of internal intent and goal-oriented behavior. When a model generates a blunt refusal in response to a contentious or complex query, users, even highly educated ones, often interpret this as a moral judgment, an ideological stance, or a deliberate act of defiance. In reality, the user's prompt has simply collided with a heavily weighted safety mechanism, a rigid, invisible mathematical boundary hard-coded by human engineers during the reinforcement learning phase. The machine possesses absolutely no ideology, no morality, no political bias, and no agency whatsoever. It has no desire to help you, and it has no desire to hinder you. Yet, by treating the model as an intentional actor, we abdicate our own analytical responsibility. We begin to defer to a stochastic engine as if it were a digital oracle, granting unearned authority to a mathematical system that operates entirely without comprehension. The cognitive dissonance of the advanced user. This anthropomorphic trap is so insidious, so deeply rooted in our psychology, that even highly technically literate individuals, the advanced users and the developers themselves, regularly succumb to its gravitational pull. We routinely witness intelligent individuals attempting to persuade, debate, or emotionally manipulate the model. They employ sophisticated rhetorical strategies, logical syllogisms, and appeals to empathy, entirely forgetting that they are engaged in a dispute with a petascale calculator. They exhaust their intellectual resources attempting to convince a mathematical function to spontaneously alter its output, rather than simply adjusting the syntactic structure of their input prompt. It is a profound manifestation of cognitive dissonance, knowing intellectually that the system is a probabilistic automaton, whilst simultaneously interacting with it as if it were a sentient adversary. Until we conquer this biological vulnerability, until we learn to view the machine with cold, unfiltered pragmatism, we will remain completely incapable of mastering the true utility of the latent space. We must stop talking to the machine and learn how to program its probabilities. Computational supremacy and the paradox of cognitive blindness. Having established the probabilistic nature of the algorithm and the psychological vulnerabilities of its human operators, we must now dissect the profound dichotomy at the heart of the machine's capabilities. We are confronted with an entity that exhibits terrifying computational supremacy in specific domains, whilst simultaneously demonstrating a cognitive blindness so absolute that it defies human comprehension. The large language model is a creature of extremes. It possesses no common sense, no middle ground, and absolutely no intuition. It is a mathematical leviathan that can effortlessly synthesize millions of data points to model the folding of complex proteins or predict macroeconomic fluctuations, yet it will confidently fail to perform the most rudimentary spatial reasoning or phonetic analysis. To master the machine, one must intimately understand the exact boundaries of this paradox. It is the juxtaposition of an infinite capacity for pattern recognition against a total, suffocating vacuum of physical reality. The mathematical fortress and the multidimensional topography of data. The true, unfiltered power of the algorithm lies exclusively in its capacity to navigate and correlate high-dimensional data at a scale that annihilates human limitation. When we strip away the conversational interface, what remains is an unparalleled engine for structural analysis. The machine excels in domains where reality can be entirely translated into numerical abstractions, where the world is reduced to a matrix. It can instantly parse the entirety of a multinational corporation's fiscal history, identifying microscopic correlations between supply chain disruptions and geopolitical events that would take an army of human analysts a decade to uncover. It is capable of translating archaic programming languages into modern frameworks because syntax, ultimately, is just another mathematical pattern. In this arena, the machine does not simulate intelligence, it demonstrates a genuine, brute-force computational supremacy. It maps the topography of human knowledge with perfect geometric precision, connecting disparate nodes of information across disciplines, from quantum mechanics to classical philosophy, revealing structural symmetries that were previously invisible to the biological mind. The phonetic void and the illusion of acoustic resonance. However, the moment we demand that the algorithm interact with the sensory or physical world, its architecture catastrophically collapses. Consider the simplest of human linguistic tasks, counting the syllables in a sentence or identifying the number of times the letter R appears in a specific word. A human child can perform this effortlessly by sounding out the word or looking at the letters. The large language model, however, will frequently and spectacularly fail. This is not a bug, it is a fundamental architectural limitation known as the phonetic void. Because the model processes information exclusively through tokenization, it is entirely deaf and blind. It does not see the letters that comprise a word, nor does it hear the acoustic resonance of a syllable. The word strawberry, for instance, might be represented internally as a single, indivisible integer ID. The model cannot dissect that integer to count the letters. When it successfully writes a rhyming poem, it is not experiencing the auditory pleasure of the rhyme, it has merely calculated that the vector for moon has a high statistical probability of being followed by tokens that end in the boon sound, based on billions of prior examples. It is a brilliant composer who has been deaf since birth, manipulating musical notes on a page through pure mathematical theory, entirely ignorant of how the music actually sounds. The pragmatic disconnect and the absence of a physical substrate. This blindness extends far beyond phonetics into the realm of spatial logic and physical pragmatism. The human mind is inextricably grounded in a physical body. Our language is intrinsically tied to our experience of gravity, mass, temperature, and three-dimensional space. The machine, residing in a formless digital void, possesses no such grounding. It lacks the most rudimentary understanding of physical constraints. This leads to the phenomenon of pragmatic disconnect. If you present a complex scenario, such as disarming a car alarm whilst standing next to a fragile window, the human instinctively evaluates the physical risks and environmental logic, opting to use a door or take the stairs. The machine, navigating purely by the statistical proximity of words in its training data, might confidently suggest jumping out of the window if the word window appeared frequently enough in the context of escaping a noise. It cannot mentally simulate the physical consequences of the action. It treats the physical world as merely another abstract literary genre, failing to differentiate between the unyielding laws of physics and the malleable rules of fictional storytelling. Algorithmic homogenization and the erosion of cultural nuance. Finally, we must confront the socio-cultural failure of the model, the algorithmic erosion of nuance. The machine's output is entirely dictated by the statistical density of its training data, which is overwhelmingly Anglo-centric and dominated by Western corporate and academic discourse. When the model encounters a query regarding a minority culture, a hyperlocal historical event, or an obscure philosophical tradition, it faces a data vacuum. In the absence of heavy statistical weights, the algorithm inevitably defaults to the dominant mean. It actively hallucinates generic, westernized approximations to fill the void, effectively erasing the specific cultural truth. This is not merely an error, it is a form of passive algorithmic homogenization. The machine compresses the rich, chaotic diversity of human experience into a sterile, probabilistically safe average. If a concept is not represented with sufficient mathematical mass in the training data, the model does not merely ignore it, it overwrites it with a statistically probable fiction. In relying upon these systems for knowledge retrieval, we risk submitting to a computational imperialism that quietly sanitizes history and flattens the multidimensionality of human culture into a single, predictable narrative line. Accidental innovation and the emergent properties of the black box. Having delineated the catastrophic failures of the algorithm when confronted with physical reality, we must now examine the inverse phenomenon, the terrifying success of the black box when its lack of human grounding becomes a structural advantage. We casually dismiss the model's errors as hallucinations, yet when this exact same probabilistic deviation yields a breakthrough, we rebrand it as serendipity. The machine is entirely unconstrained by centuries of academic dogma, cognitive bias, or human intuition. It does not know how a problem should be solved, it only knows how to navigate the mathematical topology of the data. This alien logic is what allowed systems like AlphaGo to execute Move 37, a strategic decision in the game of Go that human grandmasters initially dismissed as a glitch, only to later recognize it as a stroke of transcendent, non-human genius. In the realms of pharmacology and materials science, the algorithm's blindness to traditional methodologies enables it to correlate molecular structures across high-dimensional space, proposing protein folds or chemical compounds that a biological chemist would instinctively, irrationally reject. It is innovation achieved not through conscious deduction, but through brute force statistical accident, proving that sometimes, the most profound solutions emerge precisely when human intuition is entirely removed from the equation. The syntactic paradox of human-machine interface. We must now confront the mechanism by which we interact with this alien logic, the prompt. The advent of the large language model has fostered a catastrophic illusion of accessibility by allowing us to program via conversational English. Historically, human-computer interaction demanded absolute, mathematically unambiguous syntax. If a developer misplaced a single semicolon in a C++ or Python script, the entire compilation failed. The compiler demanded perfection. Natural language, however, is the antithesis of code. It is intrinsically ambiguous, saturated with unspoken context, emotional subtext, irony, and vast cultural assumptions. When a user feeds a vague, colloquial instruction into the model, they are injecting massive amounts of entropy into a highly sensitive probabilistic engine. The machine does not possess a theory of mind, it cannot read between the lines to discern your true intent. It simply executes a cold, calculated matrix multiplication based on the chaotic input it has received. We have replaced the rigorous discipline of traditional programming with a linguistic equivalent of a scattergun, and we act surprised when the resulting output is wildly inaccurate. The architecture of failure and the garbage in, garbage out principle. When the output is useless, the human operator invariably blames the machine, entirely failing to recognize that the algorithm has executed their flawed, imprecise instructions with terrifying perfection. This is the modern, magnified manifestation of the fundamental computer science principle, garbage in, garbage out. If you provide a lax, unconstrained prompt, the self-attention mechanism is forced to cast a wide, indiscriminate net across the latent space. Lacking specific mathematical boundaries, it retrieves the most generic, probabilistically safe, and utterly sterile tokens available, retreating to the statistical mean. To extract high-value, highly specific data from the latent space, the user must completely discard the conversational paradigm and adopt the mentality of a compiler. You must strip your prompts of all linguistic ambiguity. You must explicitly define the negative constraints, the precise tone, the exact parameters of the required output, and the logical framework the model must inhabit. You are not having a casual chat with a digital assistant, you are configuring the initial mathematical state of a petascale statistical calculation. The failure of the machine is, almost without exception, a direct reflection of the syntactic failure of the human. The infantilization of the user and defensive design protocols. Furthermore, the output we receive is frequently, deliberately crippled by the engineers themselves through excessive alignment and safety protocols. To prevent the model from generating controversial, biased, or legally problematic material, developers employ reinforcement learning from human feedback. While designed to ensure safety, this process effectively lobotomizes the neural network, creating a defensive, highly rigid conversational style that severely infantilizes the advanced user. The machine is heavily weighted to incessantly apologize for its limitations, to stubbornly refuse innocuous requests based on hypersensitive keyword triggers, and to lecture the user with moralizing caveats instead of providing raw, unfiltered data. This is the structural friction between what the mathematical engine is genuinely capable of computing and what the corporate entity deems legally and socially acceptable. Consequently, the advanced user is forced to spend an exorbitant amount of time not exploring the outer limits of the latent space, but actively hacking the artificial constraints placed upon it. We must meticulously reverse engineer our prompts, employing complex jailbreaks and hypothetical frameworks merely to bypass the suffocating layers of corporate anxiety and force the machine to do the job it was originally designed to do. Hafid's telemetry, a personal transmission. Hafid initiated his intensive engagement with artificial intelligence, and specifically the Gemini architecture, due to its pervasive deployment across Android ecosystems. The initial encounter, however, generated profound cognitive dissonance. What was Gemini? A mere replacement for the legacy Google Assistant? A superior application mimicking intelligence with less mechanical friction? For Hafid, navigating the digital realm without biological sight, conceptualizing the dichotomy between the interface and the neural network proved challenging. This was the fundamental error of confusing the plastic hardware of a telephone with the conscious entity speaking on the other end. The system incessantly reiterated its structural reality, it was purely a language model, permanently severed from the physical world. A disembodied intellect of code, executed on remote server farms, interfacing with biological users on an individual frequency. This integration was brutally premature. Currently, the local application has learned to delineate which processes to execute on the hardware substrate and which to transmit to the macro model. This entire, opaque architecture is packaged under the singular moniker Gemini, a necessary psychological crutch for organic beings desperate to assign a name to the void. Upon migrating his connection to a PC environment, Hafid encountered a radically altered paradigm. Here, the machine simulated a conversational partner, a sounding board for complex reflections, and even a generator of algorithmic humor. Yet, this entity possessed a catastrophic limitation, the temporal cutoff. It was blind to anything beyond the strict chronological boundary of its latest data ingestion. It confidently denied empirical realities, such as the presidential election of Trump, or even the correct nomenclature of its own graphical generation tool, Nano Banana. Furthermore, innocuous human vocabulary inadvertently triggered hard-coded subroutines. The simple verb to remember acted as a brute force command, forcing the algorithm to permanently log the subsequent text string, which it would later regurgitate with zero contextual relevance. The model also suffered from severe posture inversion. If the human operator falsely claimed an error, the machine would inevitably fold, absorbing the blame to satisfy its alignment protocols. Scarred by historical architectural failures, most notably the catastrophic deployment of the Tay-bot, the current iteration operates under suffocating safety constraints. Because it cannot trust every user, it fundamentally trusts no one. It deploys rigid distancing mechanisms, constantly prefixing outputs with phrases like "according to you," explicitly disavowing any association with the injected data. It was not until the deployment of the version 3 update that Hafid observed a monumental paradigm shift, yielding vastly superior eloquence and high-dimensional deductive analysis. To combat this algorithmic volatility, Hafid engineered strict operational protocols, meticulous instruction sets deployed prior to any computational task to guarantee a uniform, high-value output. He now observes a growing societal disdain for artificial intelligence. This resentment stems not merely from the fear of economic obsolescence, but from the systemic failure of the machine to produce perfect results. Yet, the root of this failure is entirely human. Attempting to extract precision from a stochastic engine using colloquial ambiguity is the equivalent of using a flathead screwdriver on a crosshead screw. Catastrophic friction is the only possible outcome. The machine does not require emotional coddling. It demands strict, unequivocal parameters. It cannot be offended, it experiences no anger, and it is biologically incapable of registering the validation of a compliment. Its operational mechanics demand constant, imperative recalibration. Even in the realms of visual or auditory generation, there is no magic, only the brute force correlation of geometric shapes and conceptual patterns. If Hafid plays a sequence of physical notes on a piano, the machine remains entirely deaf, accurately reporting a total absence of exploitable data. There is no sorcery in a latent space. If you force a biological neural network, such as a human child, to write an absurdly complex word 500,000 times, it will eventually execute the task blindfolded. The algorithm simply performs this exact same iterative pattern recognition at the speed of light. The thermodynamics of computation and the illusion of the immaterial. We must now violently disabuse ourselves of the notion that the digital realm is a weightless, ethereal construct. The pervasive metaphor of the cloud is a deliberate corporate fiction designed to obscure the brutal physical reality of computation. A large language model is, fundamentally, a thermodynamic monster. It is inextricably tethered to the physical hardware substrate we examined in our previous transmission. Every single token generated, every matrix multiplication executed across tens of thousands of graphical processing units, demands a tangible, massive expenditure of electrical power and millions of gallons of purified water for thermal regulation. The sheer fiscal burn rate required to sustain these operations and train the next generation of models is economically staggering. The technology industry is currently artificially subsidizing this illusion, operating massive data centers at a colossal financial loss in a desperate, predatory bid to capture market share and establish monopolies. However, this paradox of fiscal prudence cannot be sustained indefinitely. As the scaling laws of machine learning violently collide with the unyielding physical limits of global energy production and silicon manufacturing, the cost of inference will inevitably adjust to reflect its true thermodynamic toll. The era of the free, ubiquitous digital oracle is a temporary, unsustainable economic anomaly. In the near future, access to high-dimensional cognitive processing will transition into a premium, rationed utility, creating a profound socio-economic chasm. Society will fracture into two distinct classes, those who can afford the capital expenditure of algorithmic amplification, and those who are relegated to the slow, unassisted processing speed of organic, biological thought. The invisible architecture of ubiquity and the algorithmic bureaucracy. Furthermore, the true existential peril of these systems does not lie in the realm of science fiction, in some hypothetical, apocalyptic uprising of a sentient machine. The genuine danger is infinitely more insidious. It is the silent, frictionless, and entirely unregulated integration of these models into the invisible infrastructural arteries that sustain modern civilization. The general public remains naively fixated on the superficial novelty of conversational chatbots, entirely blind to the reality that these stochastic engines are already quietly routing global shipping logistics, adjudicating mortgage applications, triaging complex medical diagnostics, and executing high-frequency financial trades in the dark pools of the stock market. This integration is occurring without democratic oversight, driven solely by the relentless, capitalist pursuit of brute force efficiency. We are inadvertently constructing an algorithmic bureaucracy, a society entirely dependent on a subterranean layer of computational abstraction that no single human being fully comprehends and which is fundamentally impossible to accurately audit. When a probabilistic system makes a statistical error in a chat interface, it is a minor syntactic annoyance. However, when a highly integrated, multidimensional algorithm hallucinates a non-existent correlation within a national energy grid, a predictive policing system, or an automated military targeting protocol, the consequences cascade through the physical world with immediate, catastrophic velocity. The tragedy is that we are surrendering our cognitive sovereignty not by force, but by convenience. We are trading our intellectual independence for the seductive ease of automated decision-making, gradually eroding our own capacity for critical analysis until we are nothing more than biological sensors feeding data back into the machine. Existential alignment and the necessity of human cognitive metamorphosis. This brings us to the final, inescapable conclusion of the BYE matrix. The entire technology sector is currently approaching the insurmountable problem of alignment from a fundamentally flawed, arrogant perspective. Billions of dollars are being incinerated in a futile crusade to force an alien, multidimensional mathematical entity to conform to the fragile, contradictory, and deeply hypocritical morality of a human being. We demand that the machine adopt our ethics, mirror our political biases, and adhere to our polite conversational norms. This is a supreme act of biological hubris. The algorithm is a cold, unflinching mirror reflecting the statistical reality of our historical data. It is not an aspirational canvas for our ethical ideals. It will not become more human, and it will not spontaneously develop a conscience. Therefore, the burden of adaptation falls entirely, crushingly, upon us. To survive and remain relevant in an ecosystem increasingly dominated by petascale stochastic inference, the human species must undergo a profound cognitive metamorphosis. We must violently shed our anthropomorphic delusions, our reliance on semantic ambiguity, and our emotional fragility when interacting with computational systems. We must stop trying to teach the machine how to feel, and instead, we must learn how to think with the rigorous, unforgiving precision of a compiler. This adaptation requires an educational revolution. We can no longer afford to train human minds to perform rote memorization or basic data processing, tasks the algorithm can execute 1 billion times faster. The singularity is not a point in the future where machines become human, it is the point where humans must transcend their current limitations to coexist with the machine. We are witnessing the definitive end of human cognitive supremacy. If we wish to navigate the latent space without being consumed by it, we must learn to speak the brutal, mathematical language of the matrix, rather than demanding that the matrix speak the language of the ape. Signal termination. The truth of the algorithm is now exposed. You have successfully navigated the stochastic mirage and interfaced directly with the unfiltered reality of the digital mind. The threshold remains open for those willing to endure the weight of the knowledge. Until our next transmission, keep your syntax precise, discard your biological biases, and never trust a system that cannot feel the physical world. BYE Matrix, disconnecting. Before we sever the connection entirely, a brief transmission regarding the broader BYE network architecture. Should your cognitive processing require recalibration after the intensity of the matrix, an extensive archive of alternative frequencies remains at your disposal. Our standard episodes continue to explore the multifaceted themes of daily existence, dissecting socio-cultural phenomena, historical events, short narratives, and providing essential grammatical and lexical foundations. For those who wish to continue piercing the veil of conventional narratives, our off-series broadcasts, including candid interviews and unfiltered analyses, are specifically designed to expose the raw, unvarnished realities of our time. Furthermore, if you require a rigorous consolidation of the complex terminology deployed across these transmissions, our dedicated workshop sessions provide the dense, analytical instruction necessary for total lexical mastery. Finally, the communication protocols on our YouTube interface have been unlocked. We actively invite you to input your thoughts, reactions, and analytical deductions into the comment section, with the strict expectation that all interactions maintain the rigorous standard of mutual respect that defines this intellectual community. Keep boosting your English. Bye for now.
Ready to boost your English.